Okay, question number 10. The circle x squared plus y squared is equal to 13 and the line 5y plus x is equal to 13 intersect at point A and B. We need to work out the length of the chord AB, so we're looking for the distance from this point here to this point here. So the first thing we need to do is we need to decide what the coordinates of this point here is and what the coordinates of this point here is. Now these are the points of intersection, so we're looking for when this equation is true, so x squared plus y squared is equal to 13, so at this particular point here the x coordinate squared plus the y coordinate squared will be equal to 13, so that will be true. And at this point here, because it's intersecting with a line, 5 times the y coordinate plus the x coordinate is also going to be equal to 13. The same two things are going to be true at this point here, so we're looking for the two places where both of these equations are true. So we need to solve these equations simultaneously. Now, because I know the x coordinate squared plus y coordinate squared is going to be equal to 13, and I know 5 times the y coordinate plus the x coordinate is equal to 13, if I can write this in terms of the x coordinate, I can substitute that expression into this equation here. So I know from the linear equation here that x is going to be equal to 13 take away 5y. So I now want to sub this into this equation here, and then I'll only have one unknown, that is y, and I should be able to solve it. So before I sub it, because I know that I'm going to need to square it, I'm going to work out what x squared is from this equation first. So if x is equal to 13 take away 5y, I know that x squared is going to be equal to 13 take away 5y squared. I'm just going to do this over here in a little grid. So that's 13 take away 5y times 13 take away 5y, and that's going to be 169 take away 65y take away 65y plus 25y squared. So this here is going to be 13 take away 5y squared. So x squared is going to be equal to 25y squared take away 130y plus 169. Okay, so it's just that squared that I've written down over here. Now I know what x squared is equal to, I can replace this x squared with 25y squared take away 130y plus 169, and I'm going to add it to the y squared over here. So I'll write that out, 25y squared take away 130y plus 169, so that's that bit, plus y squared is equal to 13. And if I simplify this, and I'm going to subtract 13 from both sides because I want it to be equal to 0, I'm going to have 26y squared take away 130y, yeah, so I've added that y squared to that 25y squared to get that, plus 169, but I'm going to subtract that 13, so it's going to be plus 156 is equal to 0. Now, quite a handy thing that's happened here that you may or may not spot is that 26 is a factor of all of these numbers. So if I divide through by 26, that becomes y squared. Take away 130 divided by 26 is going to be 5, so that's going to be take away 5y. 156 divided by 26 is 6, so plus 6 equals, and 0 divided by 26 is just 0, so that's going to stay as a 0. So I now know that y squared take away 5y plus 6 is going to be equal to 0. If I factorise that, I've got y take away 2 times y take away 3 is equal to 0. I now know that the y coordinate of both of these, y is going to be equal to 2, or y is going to be equal to 3. Okay, so this is our y-axis here. So the 2 is going to match with this one over here, so this is going to be something 2, and this here is going to be something 3. Okay, the y coordinate of this point B is 2, and the y coordinate of this point A is going to be 3. I now want to decide what the x coordinate for each of these is going to be. So for when y is 2, so for this one, I can work out from here that x is going to be, well, 5y would be 10, so x is going to be 3. So that's going to be 3, 2. And for this one over here, I don't know why I've written y is equal to x, I meant to say y is equal to 3. Okay, so for this one here, the y coordinate is 3, so that would be 15. So x is going to be negative 2. I'm going to put negative 2 here. So all I've done is I've substituted my y coordinate into this equation for both cases. I could have done it into this equation as well, it's just easier to do it into this one. Okay, so let's just check whether this works in both equations. So my x coordinate squared plus my y coordinate squared is equal to 13. So negative 2 squared is 4, 3 squared is 9, 4 plus 9 gives us 13. So it works for that set. Let's try this set. 3 squared is 9, 2 squared is 4, 9 plus 4 does give me 13. So both of them work in that equation there. Let's try in this one. 5 times my y coordinate plus my x coordinate is equal to 13. So 5 times 3 is 15, plus negative 2 does in fact give me 13. Let's try it for this one. 5 times my y coordinate, so 5 times 2 is 10, plus 3 gives me 13. So both of these points work in this equation as well. And in fact, these are the only sets of coordinates that would work in both of these equations. And that's why there's only 2 intersections between this circle and this line. Okay, so we now need to move on to the next part of this, which is to work out the length of the chord AB. So I now know these 2 points. I need to decide, well, what's the distance between these 2 points? So in order to do this, we need to kind of turn this into a triangle. Okay, so we're going to turn it into a right angle triangle. This is going to be point A, and this is going to be point B. Now, the height of this triangle is going to be the difference between the y coordinates. So it goes down from 3 down to 2. So that means that this length here must be 1. And the difference between the x coordinates is going to be, well, it goes from negative 2 here to 3 over here, which has a difference of 5. So it has gone along 5 over here. So the distance between A and B, using Pythagoras, is going to be the square root of 1 squared plus 5 squared. So AB equals to the square root of 1 squared plus 5 squared for AB is going to be equal to the square root of 1 plus 25, which is 26. And the square root of 26. And we could, if we wanted to, use our calculator, but we can just say that the length of the chord AB is equal to root 26. There aren't any units here, it's not in centimetres or metres or anything like that, so we can just leave it as a value of the square root of 26. Okay, I'm just going to show you quickly exactly what we've worked out and how we've worked it out. So we've worked out this distance from A to B, and this is the triangle. Not done a very good job of that. Let's try that again. Okay, so this is the triangle that we've just used. So this had a distance of 1 because we went from 3 down to 2, and this had a distance of 5 because we went from -2 on our x-axis to 3 on our x-axis, and we've worked out the length AB. Okay, I hope that was useful. Thanks very much for joining me. I'll see you next time.